Okay, today's lesson, we're going to look at thermocouples. So by the end of the lesson, we should be able to describe the structure of a thermocouple, and also we should be able to understand why it's used and its use as a thermometer for measuring high temperatures and those that vary rapidly. So in previous lessons, we were looking at liquid and glass thermometers. We also had the infrared thermometer out for a bit, and they're both useful. But today we're going to look at a thermocouple, which is a thermometer that you may not be very aware of. Now, I think the best way to describe a thermocouple is if I just describe how a thermocouple is made. And quite simply, it's made from two bits of wire. What you do is you get one bit of wire, and it could be any type of wire at all. Different combinations work better with each other, but let's just imagine that this is, I don't know, let's just say it's iron, for example. And then you're going to connect it up to another wire, and this wire could be anything at all. And let's imagine that this wire is, let's make that line a bit thicker as well. Let's imagine this wire is copper. Okay, so two wires that you're quite familiar with. And what you do is you're going to twist the ends of the wires together, and these twists are going to make junctions. Okay, so this here is a junction, and this also is a junction. So they're physically connected together. Now then, my copper wire, the big longer wire that I got here, I'm going to connect that to a piece of equipment, and I'm going to connect it to, now, depending on where you look, you might see different things, okay? We're just going to say a voltmeter, all right? Plain old simple voltmeter. You might see it sometimes, a millivoltmeter, because there are very small voltages involved, or even sometimes you'll see it connected to something called a galvanometer, okay? And a galvanometer, kind of similar to a voltmeter in some ways, that it measures some kind of electrical value, but we'll just stick with voltmeter because it's nice and easy and you're familiar with that. Now, this is a thermocouple. So two different wires, copper, and I stress that both these bits of wire are copper, and then you've also got your iron wire by here, okay? And they're connected together at the junctions, and each of these junctions has a name. We call one of them the hot junction, and one of them the cold junction. And this is very important because the way that a galvanometer works, sorry, a thermocouple works, is that when you have a hot junction in one object and the cold junction in a different object, and they're different temperatures to each other, you end up with a potential difference, right? You end up with a voltage being measured by here. And we can use that voltage to tell us the temperature of the objects. Now, let me just show you over here. So some diagrams I drew earlier. Here I've got some ice and I've got some coffee. Now, if I was to put my one junction into the ice, and if I was to put my other junction into the coffee, I'd get a reading on my voltmeter, and that reading would tell me what the temperature is. So how do I convert the electrical reading into an actual temperature? So that easy. Two methods. Either you can have a calibrated galvanometer, okay, or voltmeter even, sorry. So calibrated voltmeter slash galvanometer. And what I mean by that is that just like when you calibrated your liquid and glass thermometers we made in lessons a few weeks ago now, you could work out what particular voltages of my voltmeter would correspond to what temperatures. Now, we call one of these cold, one of these hot. We can sometimes call one a reference junction, and often that'd be the cold one, because in order to know the difference in temperatures, you need to know what temperature this reference junction or the cold junction would be at. So for example, another method would be is if I've got two particular metals, I would have a reference table like this one by here, and depending on the temperature difference between the two junctions, then I would get different voltages, okay? So I've got a reference by here, I've got 1 degree there and 20 degrees there, and I would expect 838 millivolts to be my reading on my voltmeter. So that would be another method of determining the temperature from the voltage reading I get by here. Okay. Now an important point of this is that say now I've got this situation where I've got 2 hot cups of coffee and both my cups of coffee are the same temperature. If I was to try using my thermocouple to read this temperature, then it wouldn't work. Okay, voltmeter would not register a voltage because there's no temperature difference. So it's very important that we remember that thermocouples register a voltage if the junctions have a temperature difference. Okay. Uses of our thermocouples. Some big uses as well. The reason why we might want to use a thermocouple over a normal traditional thermometer is they are very quick. Right? They register temperatures almost instantly. And then the other reason is that we can register very high and very low temperatures using a thermocouple, which we might be limited with a liquid and glass thermometer or even infrared thermometer as well. Now then, that's pretty much all you need to know about thermocouples. You can have a little look on the internet. There's a video which I'll share a link with in the Google Classroom, which will tell you a little bit more about them, or at least it'll tell you what I've just told you there. And what I'd like you to do is once you've had a look at that video and you've read through this and listened to this presentation as well, you can have a go at filling in the blanks by here. Okay, so all I want you to do is on a Word document, very quickly fill in the blanks and submit this to the Google Classroom assignment.